Before we get going, anybody know why the pony couldn't sing a lullaby?
Why? It's not moving. God, I hate that.
Little horse.
My joke's better. The kids.
Ponies are little horses. A little horse, like when you gotta talk like this a little bit.
Yeah, my joke's better. The KFC joke.
KFC joke. All right, 3 warm-up problems. Go for them.
Oh yeah.
Go for them. Time to shine. All right, so we got 1/2 times 10 over 1. Is there anything that we can reduce before we start?
Yeah. No.
Yes. 2 goes into
10. 2 times.
So 2 once, and 2 goes into 10 5 times. Multiply straight across. Gets me 5 there.
If you did it the other way, you would have 10 over 2.
10 over 2.
Which is also 5.
Which reduces to 5. Yep.
Oh, dude.
All right, guys, that's it.
Yep.
My bad.
2/3 times 12 over 1. We'll do that one the other way, where we get 24 on top, and we get 3 on the bottom. 24 divided by 3 is 8. We could if we wanted to reduce first. Yep. 6/5 times 15 over 1 is going to be, ooh, that's going to give me a big number on top. So let's divide first. 5 can be divided by 5 once. 15 can be divided by 5 3 times. Makes it a nice, more manageable type number. Answer is 18.
15 can't go to 8.
What was that?
15 can't go to 8.
That was 5.
That's a 5.
That's like an 8 when you cross it out.
Yeah. You want me to back it up and show you?
I was about to say, I was confused for a minute there.
There you go. There's Jake.
One more.
Jake, there's your 5.
That's an 8.
There's your 5.
That's 5. That's an 8.
All right, any questions on those 3? A little bit of review.
All right. So yesterday we talked a little bit about the distributive property. And remember I told you what was the key that I still use in my advanced middle-aged life? Arrows. We still draw arrows. So this A out in front here has to get multiplied into the B. And then it's got to get multiplied into the C so that we get AB plus AC. There. Okay. Do something. All right. So what I would like you to do now is, so example A and B here, they're the exact same example. We're just going to do them in both different ways. Okay. So the first way is using an area model. That's kind of like what we did yesterday in class, where we take this outside number here and we put it out in front. Then we take this inside first term and we put it there. And we take this inside second term with the sign and we put it there. Then we multiply these. 3 times 2x. Come with 6x. We multiply these. 3 times negative 7. Ooh, negative 21. Yep, couple too many there. And so then we combine those two into one line that says 6x minus 21. Okay. Without an area model, because that's what we're going to, because let's be honest, area models take up a lot of space. Okay? So without the area model, that's where those humps, those arrows come in. So we have to go 3 times 2x is going to be 6x. 3 times negative 7 is going to be negative 21. And you see, we get the same answer. With that being said, try letter C in either method. I don't care which method you do, but try letter C right now. So what happens when I multiply that x in? What do you got, Adrian?
X times X equals 2x X squared.
Start over.
Start over again. Start from the start again.
X times X equals X squared.
Okay, then what about the 8?
8X.
So then that gets times 8 and gets me 8x squared, right?
Yes.
Okay, because in my brain, what we're doing here is we're doing x times 8x, right? Which is 8 times x, which you said the x times x is x squared. So then that's 8x squared. Okay, I would agree with that. Then, oops, this color. Then what's this one going to be? What's x times 5? 5x. Okay? So our answer here then would be, since this was plus, that's going to be a plus in there. So our answer here would be 8x squared plus 5x. Okay? Thumbs on that one. Thumbs up, we got it. Thumbs to the side, we missed the squared. Thumbs down, totally didn't get it. Okay? If we did an area model, yep, we'd have 8 and 8x and plus 5. There's our 8x squared. There's our 5x. Okay? And then we could also add in here, if we put it in the plus there and the plus there to keep our signs going, we'd be good. Okay? Now, a couple of you worked ahead. And then I went around and I showed you this part right here. Okay? So, how can we show work on these problems? Give me one way.
Show how you did it. Show how you got the answer.
Yep.
Like how?
What's one way to do it?
What's one way to do that?
Do step by step.
Okay. Nora, give me one. Okay. So we could write it out. Yep.
So how'd you show it?
But how are we going to show that? You did it. You did it. I watched you do it. You do the arrows. Yep. One thing. Bare minimum, you should show the arrows.
I did that.
Okay. All right.
Buddy, stop paying for PK.
Okay. What's another way of doing it? Mr. H just showed it to us on that last one.
You write it down. Like you go step by step.
Like the area model? Like that? That's what,
You call them area models or generic rectangles or
same, all the same.
Yeah, like that.
Like that thing right there? Or like this, yep, okay? We gotta show something. We cannot just be giving answers. Okay? Alright? So we gotta show something. So 4 times B here is 4B. 4 times positive 7 is positive 28. So we would have 4B plus 28 there.
now do they need to write out all of that stuff, or if they draw the arrows, are you okay?
Minimum, you got to draw the arrows.
Alright.
Okay? Okay? Minimum, you got to draw the arrows so that you know. Okay? Do numbers 2 through 6. Actually, let's do 2 through 4. We'll save the fraction ones. We'll reconvene and we'll go over the fraction ones too. So 2 through 4 right now.
Come here, please. Number 2. Whoa, we gotta hit this. Draw your arrow.
Okay, so minimum you got to do that, right?
Negative 9a times an a.
Negative 9a times an a.
Negative 9a squared. Negative 9a times a positive 3. Negative 27, but don't forget this a. We got that? Next one. Draw arrows again. N times 4, what do we get? 4n. N times a negative n. That's great.
Now, how would what would standard notation on that one be? We'll accept that,
Sorry.
but making it easier for us, what would standard notation of that one be?
1 and 2.
What we wrote.
Put
Another
what in front?
1.
In front of what? Just leaving it in that order?
Yeah.
No.
What did we talk about last week?
Standard form of a polynomial or an expression, what comes first? The biggest exponent comes first. So we've got negative n squared plus 4n.
Thank you, Mr.
Yep, plus 4n. That would be standard form. So if we ask for it in standard form, those biggest exponents come first. Okay.
All right, last one, number 4. Whoa, wow. Okay, first we have negative 3x times y. What's someone get for that?
Minus 3x.
So we have a negative 3x times a negative z.
That's positive. So plus 3xz. Yep. Now, when you have double variables like we have there is no standard form, okay? But we write the variables in each term in alphabetical order. So the way that Mr. H wrote that there is the way that we would like to see it because it's in alphabetical order.
Okay, you got your alphabet, there you go.
The last three of the alphabet. Okay? All right, let's go to the last two. Okay? So now we've got a fraction in front, right? Does anything change?
No.
No, nothing changes with how we do this, okay? We still take that first number, that outside number, and we multiply it into both. Now here on these, you're probably going to need to show more work, okay? So you would need to show what Mr. H is showing right now, where it actually is written out. So now it becomes like those warm-up problems that we did at the top of your page, okay? So 1/3 times 12x is how much? Do we agree with 36x?
Yes. Very.
Or what if I rewrite it like this?
Yeah, let's rewrite it. Now what is it? 12x over 3, right? Can 12x over 3 be reduced
Yes.
to what?
Or
4x. Yep, 4x there is that first term. So you see how there's a little bit more work that needs to be shown when fractions come into play. Okay, then we got to go to the next one, and the next one now is 1/3 times what? What kind of 15? Times negative 15. Yep. Okay.
you wanted to rewrite that?
Nope.
I'll write it as that. And if you want, you could, yeah.
Yep, so it'd be negative 15 over 3 or just flat up negative 5, right? Okay, so then our answer becomes 4x minus 5, right there.
Write that.
Yep, and then we can put that in our answer. Okay, you try number 6 now. Okay, you
Okay.
try number 6.
And as you get more proficient in these, the more practice you do, you'll have to probably show less and less work, but right now it helps to just write everything out.
Yep.
Just please, start with the arrows here. 1/2, you guys give me your attention for a second. 1/2 times 14x.
That
What
is
is
7x.
Yeah.
7 same. Hey, we're not.
That's 7 flugins.
And then 1/2
That's 4 flugins.
Yes, times -8, so I'm gonna write that up.
-4 blue you.
And this would be your final answer that you could put. So 7x minus 4y. This is a positive, this is a negative.